Our planet is more than 70% covered by water, but the world ocean is not just a static, gigantic mass. It is a living, constantly moving organism. It is precisely its interaction with the atmosphere that determines the Earth's climate, and therefore our entire lives. For centuries, mariners have sought out ocean currents to reach their destinations faster. But currents affect more than just ships. Coastal residents feel their power firsthand. Sometimes cities located at the exact same latitude experience radically different climates, and it is all thanks to these invisible ocean rivers. Today, we will not just cover the basic school geography, but we will look much deeper. We will learn how our planet's global ocean conveyor belt works and why ordinary plastic ducks helped scientists unlock the secrets of the ocean.
To start, let's understand the rules of the road. The main conductor here is the Coriolis effect. Due to the Earth's rotation on its axis, ocean currents in the northern hemisphere twist clockwise, and in the southern hemisphere, they move counterclockwise. But this is just a general blueprint. In reality, everything is much more fascinating. Currents are divided into several types. By depth, surface currents are light and fast, born from winds. They carry only 10% of the water volume. And deep currents are slow but colossal in power, running at depths from 400 meters to several kilometers. They account for the remaining 90% of the water conveyor. By temperature, warm currents usually rush from the equator toward the poles, while cold currents head back in the opposite direction. It is important to understand that an ocean current is not a railroad or a highway. It is more of a vector. In 1992, a merchant ship sailing from Hong Kong hit a severe storm. One of the containers was washed overboard. Inside were 29,000 plastic bath toys, with yellow ducks becoming the most famous. In the years that followed, these ducks were found all over the globe, in North America, Australia, and Asia. But they did not arrive as a single group. They were scattered across thousands of kilometers. This case clearly proved to scientists that ocean currents constantly shift their shapes and depend heavily on seasons, winds, and weather. Let's begin our journey with the most powerful and crucial current on the planet. It spans across all meridians in the south of the Earth and carries a colossal volume of water, up to 140 million cubic meters per second. We are talking about the Antarctic Circumpolar Current, or the west wind drift. The famous James Cook was the first to describe it. He noted that between the 40th and 60th degrees of south latitude, a constant western wind literally drives the water and ships eastward. Later, Russian navigators Bellingshausen and Lazarov skillfully used this current to discover Antarctica. This current works in tandem with the cold, deep Antarctic bottom current. Together, they start the climate engine of the southern hemisphere. The west wind drift gives rise to three powerful surface currents that rush northward along the continents: the Peruvian, Benguela, and West Australian currents. Look at how this impacts human life. The cold Peruvian current runs along South America. The water above it evaporates, but due to low temperatures, it cannot rise high enough to form rain clouds. The result? One of the driest deserts in the world, the Atacama, was formed on the coast. Yet this very same current has a generous flip side. This area experiences powerful upwelling, the rise of deep waters to the surface. Along with the cold water, phosphates and nitrates rise from the bottom, serving as ideal food for phytoplankton. Billions of anchovies and sardines follow the plankton. Thanks to this phenomenon, Peruvian fishermen boast one of the largest annual fish catches in the world. Moving further toward the equator, the cold southern currents warm up and turn into the warm south equatorial currents in the Pacific, Indian, and Atlantic Oceans. Right at the equator, where the winds of the two hemispheres collide, a curious phenomenon occurs: the equatorial countercurrent. It moves against the main water masses, from west to east. In the Atlantic, it is this current that gives birth to the warm Guinea current in the summer. Here we also encounter seasonal currents that change direction depending on the time of year due to monsoons. For instance, in the Yellow and South China Seas, cold winds blow from the north in winter, dragging cold water with them. In summer, everything reverses completely, and warm equatorial waters rush from south to north. An even more astonishing example is the Somali current in the Indian Ocean. In winter, it is warm and flows south. In summer, monsoons turn it northward and it becomes cold. How can a current become cold right in the middle of the tropics? It is all due to that same process of upwelling. The wind blows away the upper layer of water, causing deep water masses to rise. For these parts, the water temperature drops to around 22 degrees Celsius, a true natural air conditioner for the region.
Let's cross over to the northern hemisphere. Here we are met by what is perhaps the most famous and fastest warm current in the world, the Gulf Stream. It originates in the Gulf of Mexico and races along the coast of North America. But rushing to meet it from the Arctic is the freezing Labrador Current. The meeting point of these two giants is an iconic and dangerous place. It was right here on April 14, 1912, that the ocean liner Titanic was charting its course. The collision of warm air from the Gulf Stream and freezing water from the Labrador Current often creates an absolute calm and optical illusions, mirages. According to one version, the contour of the fateful iceberg literally blended into the horizon due to a mirage, causing the lookouts to spot it too late. Furthermore, having entered the cold current, the iceberg had partially melted, flipped its dark side up, and barely reflected the night sky.
But let's return to the Gulf Stream. In reality, it is not just a surface river. Its influence reaches depths of up to 1.5 kilometers. It is this current, transitioning into the North Atlantic Drift, that warms up old Europe. Amazingly, by planetary standards, this heater turned on quite recently, about 3 million years ago. Before then, North and South America were not connected. When the Isthmus of Panama rose, it blocked the free flow of water between the oceans. The warm masses were redirected north, warming the North Atlantic by 6 to 7 degrees. It is thanks to this current that today, Murmansk, located beyond the Arctic Circle, remains an ice-free port. In the northern hemisphere, the Gulf Stream loops into the Canary Current, forming a giant gyre. A similar system operates in the Pacific Ocean. There, the warm Kuroshio Current transitions into the North Pacific Current and loops back via the cold California Current. We have arrived at the grandest concept of all, the Global Ocean Conveyor Belt, or thermohaline circulation. There are only two main spots on the planet where surface waters sink all the way to the ocean floor. The first is in the North Atlantic, near the southern tip of Greenland, and the second is in Antarctica, in the Weddell Sea. In these two zones, the water becomes as cold and salty as possible, meaning it becomes extremely dense. It grows heavy and plummets downward. These are the two most powerful engines of our planet. As it sinks, this water begins its slow journey along the ocean floor. To travel from Greenland to the Pacific Ocean, a distance of 40,000 kilometers, a single drop of water needs anywhere from 1,500 to 2,000 years. To us, it's an eternity. To the planet, it's a mere second. The deep currents of the conveyor belt do not rely on changeable winds. Their movement is driven by differences in temperature and salinity. This eternal engine operates without a single pause, carrying heat, oxygen, and nutrients across the entire globe. In nature, everything is interconnected and exists in a fragile balance created over millions of years. Surface winds and icy depths work together like a single clockwork mechanism, making our planet habitable. If you enjoy diving into the depths of the world ocean, leave a like, subscribe to the channel, and be sure to share your thoughts in the comments. See you in the next episodes.